2003 Honda Odyssey with a 3.5 liter engine. It has a dead miss at idle. The garage that I'm working at has already disconnected the catalytic converter for fear of a restriction, so it's going to be a little bit noisy. And what I want to do with you guys is do a low-tech version of identifying which cylinder is misfiring. So I'll start it up, let you hear it first. I'll let you see the hood. The shaking of the hood kind of shows you the miss, maybe more than the sound. I'm not sure how well the sound will show up, but you can see the hood shaking in a pattern that matches exactly what this misfire is. So it has a dead miss for sure. Okay, so the first thing I'm going to do is a cylinder drop test, and I want to warn you guys that this method to start with this is you're going to set trouble codes. So I haven't scanned the car or anything. I don't even know what codes are in there, but when you start unplugging coils, you are going to set fault codes. So this may not be the best first approach, but I realize some of you don't have a scan tool and you want to know how to find a misfire on a vehicle like this. It can be done. One other point is, to do this test, it really needs to be a dead miss. If you have an intermittent misfire, doing this cylinder drop test by unplugging coils, it's really not going to be that helpful. So I'm going to do the front three. Hopefully you guys will hear the difference in the RPM as I unplug them. So you got lower, plug it back in, listen to it. Off, on, off, on. Now some of you guys have made comments in the past about the potential for arcing the computer, the coil, by unplugging the connector. The answer is no. These coils produce way more arcing on their own without unplugging them. Just the primary event is a huge voltage spike. I'm not worried about hurting anything here. This one's good, this one's contributing. Next one. That one's good too. I heard the RPM change. On and off, listen to it. That one's good. Last one on this front bank. That one's good too. Back three. Now can I get you a camera shot of what I'm doing? I'm not gonna get a camera in there, but you guys can kind of watch what I'm doing. There's the first one. Off, on, off, on. That's a good one. Middle cylinder in the back. It's disconnected, reconnected. Off, on, off, on. No contribution, middle cylinder in the back. One more. Off, on, off, on. I'm just pulling the connector on and off so you can hear the RPM changes. Again, that middle cylinder, I'm pulling the connector on and off right now. 0 changes. All right. Okay, so next step is we need to address this middle cylinder in the back, and we could be dealing with a spark problem, fuel problem, or compression problem. Just trying to make this easy, I think what I'll do next is I'll just pull this coil and plug out of this back, and I'll move it to one of my front cylinders, and then we'll redo our RPM drop test. gonna swap it with this one up front. In part up front because if I end up finding a bad component, it'll be easier to change it up front. It's the middle cylinder in the back. There's actually a lot of room to work, surprisingly, on this. And you guys, of course, that are following me understand my desire to use my equipment more than do this type of thing is, oh, that looks like crap too. There are times, guys, that I can't get to these coils. If the intake manifold extended over the valve cover, how do you pull the coil and pull the plug and move parts around when the intake covers it? There's other ways to identify faulty components, and that's really what I try to show mostly, but this works too. I use this method a lot. There's no reason to go crazy when you have an easy system like this. So the coil is out. Is there carbon tracking on that? It looks like it had some water in there. I don't go by this color on the boot too much, but what I look for inside is a carbon track. Let me look closer. In fact, I'll throw in an image of what I look for right here. I do not see any carbon track in this coil. And I'll put a picture, this is actually out of my book, of a carbon track and what they look like. You see in this picture, compared to the boot that I'm holding, you know, that's what I'm looking for, and I don't see any of that in there. So that's the coil. I guess I'll leave the plugs alone. Let's do it that way. I normally would do the plugs and the coil at the same time. Let's just swap the coils first. We'll leave the plugs where they are, okay? So I was going to move the plugs and the coil at the same time. We'll do it separately. Move this coil that was in the back up front. I'll put this one that was firing back here. I don't know my cylinder layout, so I'm not sure exactly what cylinders are what at this point. It really doesn't matter. Now there's another variable here, guys. That back plug, if this coil is bad, that back plug is going to be wet, and we need to give it a minute to dry itself off from the combustion that would now be taking place in the cylinder. So we may have a 2-cylinder misfire here, at least for a little bit. But my main focus is going to be with this front one, not so much what the back one's going to do. Because if the coil is bad, the fuel injector's still spraying, so that cylinder is definitely washed with fuel. The plug is definitely soaked, if this is the case. All right, I'm gonna start it. We're gonna focus on this front one right here. Okay, disconnecting. No change. No change. Bad coil. This back one. It's the middle in the back. Wait, that wasn't the middle, sorry. Here's the middle in the back. On and off. Let you guys listen to it. I'll stop talking. So cool. No reason to move the plugs around. I identified this coil as being faulty, no question about it. So I know some of you are thinking, that's it? Come on, Danner, you got to give us more than that. I'm going to. We'll put the scope on it. Let's see what this waveform looks like. But I also want to let the rest of my viewers know that we don't need to have fancy equipment sometimes. We can just use our heads, move things around, and as you saw in this case, absolutely a faulty coil. Very, very easy to do. This is a 5-minute job, really, off camera, doing something like this. RPM drop test by disconnecting coils. It does work. There are some variables to that. Toyota, for example, would use the signals from the coil to fire the injectors, and so what will happen on a Toyota, you unplug a coil and then the car shuts down. So this test doesn't always work, but it's a very valuable one to learn. So we have a confirmed faulty coil. We didn't hook a scan tool up to it. We didn't use a scope. The only tools that I used were my fingers and a little 1/4-inch ratchet with an Allen key on it. That's it. So let's go back to it now, and I want to show you the waveform on this front coil. Okay, so the scope I'm using for this is a Pico scope. It is a laptop-based scope. And I'll throw in the scope screen right here. And I'm just going to use an amp probe set on a 20 amp setting. This is a 3-pin coil. So this coil design, it would have a main feed, it would have a main ground, and then it would have a pulsed control from the computer. Knowing Hondas, this black and yellow is most likely my main feed. I'm going to go after that one. Amp probes are polarity sensitive, so the arrow inside the jaws of this would point toward conventional theory current flow. So I'm going to point that toward the coil on that wire and then plug it in. And again, the idea of using an amp probe on a coil like this is we can read coil issues from the fuse box if we chose to. And I didn't pull a wiring diagram. I don't know if these coils have a main feed. We can actually take this measurement from a fuse box in the case, say, an intake manifold would cover the whole engine. Let's see what this waveform looks like. I'll do my settings on the scope. I need to tell my scope what I'm using, which is my amp probe. .60 amp current clamp in the 20 amp mode is what I've chosen. Knowing ignition coils draw between 6 and 10 amps on average, we'll do this setting, which is -5 to 10 amps. I'll move my 0 line down. And then as far as a time base goes, most ignition events occur about 5 milliseconds long. So a 50 millisecond screen should be decent. Let me start it, see what we got. That's pretty cool. That is a great view of a shorted coil. Let me set a trigger to make this thing stop walking. That is a shorted secondary winding for sure. Some of you are thinking, well, it looks like a primary winding short. Well, I've been fooled by these before. Let me zoom in on a little bit more before I make a definitive call here. Yeah, that's a shorted secondary, guys. Let's move this trigger over. Yeah. No straight up lines. If this was a straight up line right here, I would say shorted primary. The secondary coil has a lot of influence on this first section here. I'll put a link right here to another video I did where I did the same thing. It was on a Chevy truck that I initially called a shorted primary, but ended up being a shorted secondary. This is a shorted secondary for sure. And I stop at secondary because, and not say secondary winding, because you could have a spark plug that's shorted. In fact, I'll throw an image up right here of a plug that was smashed together that caused the same kind of pattern. So we need to be careful. There are some variables with this test too. If your plug end is smashed like this picture, effectively that's shorting out the secondary winding. Now we know that our plug is fine because this cylinder we moved the coil to was firing before. So now we can confidently say this is a shorted secondary winding of the ignition coil. Okay, so I saved that. Now I'll jump this over to the coil next to it so you guys can see the difference. amperage is a lot higher. So we're kind of cutting off the top of that. But that is a good looking pattern. This oscillation here at the beginning is a little crazy looking. Normally we'll see a smooth oscillation there. I'm not going to read too much into that. But this is what we want to see, this kind of slope. And some of these, by the way, you can't really see these oscillations all that well. What I look for in these oscillations, I'll throw another image in here. This is a comparison in my book I have on the turn-on oscillation, where you see the top image here is a good one to my right, and then the bottom one is a bad one, a shorted secondary. And again, so that's what we look for, is those types of things. But this is a good looking ramp compared to what we had. I want to resave these pictures. I'm going to set this, because I didn't realize how much higher the amperage would be. I'm going to set this to a 20 amp. We'll use that image there. Let's see. And I'm going to redo my other one, the bad coil, again. Save that one. Nice little feature of the Pico here, guys. If I go to my tools and I go to my reference waveforms, let me delete this one first. I'm going to take channel A, which is this one right here. If I double click it, I just made a reference waveform right there, okay? And hit OK. And then from there, I just hit my page down button on my screen to open up my other file. This is my good coil. What's nice about laptop based scopes, you can do so much. So take this pattern, and then what I can do is go to my tools, go to my reference waveforms again, and then open up the other one, hit OK. And there's my good and bad coil. I should have saved that differently. Okay, I'm gonna redo this one more time just to make a better reference waveform. The trigger points that I'm saving have moved these coils in a different location because of where that trigger point is on each of the patterns. So what I can do to make this a little bit more user-friendly is, first of all, let me turn this reference waveform off. And I'll redo this one. But now what I'm going to do is, instead of the rising edge for the trigger, I'm going to set this to a falling edge, okay? And then I'm going to move this point over, a little bit of delay, and I'm going to save it there. So file, let me freeze it, and I only need the one image. Save. And one more time, I'm going to move my amp clamp over. That's my good coil. Freeze that. Okay, let's do this one more time now. We go to Tools, Reference Waveforms. I'm going to delete that one. This is the channel I have open. If I double click that, there's other ways to do it. Double clicking it works. I just made a reference waveform there, and now I'll open up my bad one, either by using my page up, page down on my keyboard, or this. There's my bad coil. Let me shut this car off. We are still spraying fuel. There's multiple ways we can find misfires. This exhaust stinks real bad, which is suggesting we're getting fuel. And you know, some of you are worried about the cat. I agree, but remember the cat is unbolted right now. All right, here's my bad one. And I'll open up my reference waveform, turn on my good one. And that's a real nice comparison of the two coils and their reaction and how they're operating. It's an awesome feature of the Picoscope, these reference waveforms. You can do all kinds of measurements in here. But no reason to really go too much further into that, just showing you what a known good one would be compared to a shorted secondary is pretty phenomenal. This line in my reference waveform, you see how sloped it is right away. That just really has to do with counter electromotive force and all kinds of theory involved there. But this is the kind of stuff, guys, we can see from fuse boxes. Now think about that for a minute. Imagine this vehicle for a second. Imagine that we couldn't get to anything under the hood. Let's say that the intake was covering, everything. We could potentially go right from a fuse box, install a jumper, and put our amp probe around the jumper and see all of our coil firing events and see a waveform like that and say, hey, we have a coil issue for sure. All right, so for you guys that haven't seen me do this in the past, I'm just going to describe it. I'm not going to actually do it because the coil, there's no fuse in here for the coils for this car. But here's how this would go. Is we locate a fuse that would feed all the coils. Not all cars have them. And what we do is we'd install this in its location, this little current loop. This would plug in where the fuse goes. And then what you do is you take your amp clamp, and now from the fuse box, we could potentially read all of the coils. Now, how do you know which one is which? Pull in a second channel. We hit this computer wire, which would be, in this case, this tan wire. Then we need to know what cylinder that is. And this signal right here that would be occurring for this coil, turning this coil on and off, would synchronize all of my signals here. I'll throw in a couple links here to videos where I've done this for you guys that want to learn how to do that. And then really from just looking at my waveform on my laptop, I can say, hey, we have a shorted whatever cylinder. I can identify the exact cylinder, which is underneath the intake manifold, and then go right to it. So that's cool stuff. All right, I'm not even going to bother going inside looking for codes or anything like that. I think that's good enough for this vehicle. This garage owner told me that it had a CAT code when it came in, and that's it. No misfire codes. So anything that was said in here right now would be from me. One last comment. I'm going to tell the garage owner to put a set of plugs in this too. Just insurance. We can have a plug problem, high resistance problem in a plug that can end up shorting out a secondary winding of a coil. So I'm gonna have them put a set of plugs in it just because, and then one coil, and this is my bad coil right here up front. One final piece, guys, is clearing the fault codes, and I'm actually going to do that with a little Bluetooth device that I just got. It syncs up with my phone. This is the company that I got it from, and this guy just plugs right into your data link connector. Then I go to my app, which is available on the Play Store, and then I connect to it, and it should be this one right here. I have a few of these, so that's the difficult part. So when you have a couple of them, it's which one are you using? Alright, so we'll just go to read codes. And we have a heater code for the downstream O2. I didn't know that. I'll have to let Pete know about that. There's all of our misfires. That would be from me doing my thing. And then what's this one pending code too? It's 1399. These P1 codes, so this is the downside of using a generic type scan tool, is we don't have the definitions for those, but that's not hard to find out. We can pretty much Google stuff like that nowadays. This P1399, it is ignition system related. Probably has to do with me disconnecting components. Let's see if we can get a description here. This, I think, is from their site. I don't want to enter a VIN right now. You guys, before the days of the computer, you don't understand how awesome this is. I'm just, that first line, P1399, random cylinder misfire detected. So that's Honda's version of a misfire. All misfire related. I have to let this garage owner know that I did not see a cat code in here. And that he needs to know about this downstream O2 fault. That's pretty cool. Bank 1 sensor 2 O2. So pretty neat little tool. And what I'm going to do now is clear them. And then start the car, see if my check engine light's off. Okay, cool. No, just came right back on. Oh. That O2 heater circuit, he's probably got that oxygen sensor disconnected. That's what that is. Okay, cool. Well, I'll show you some other features of this scan tool another time. Right now, that's good enough. Just being able to get in and read codes, clear codes with a little inexpensive Bluetooth scan tool is pretty cool. Technology's awesome. Alright guys, that's it. I will see you next time.